let's look at some standards for triangles. This is in 7th grade. So draw freehand with ruler and a protractor and with technology geometric shapes with the given conditions. Focus on constructing triangles from 3 measures of angles or sides, noticing when the conditions determine a unique triangle, more than one triangle, or no triangle. So what does that mean? In 7th grade, we're going to investigate triangles on a deeper level. So, though there are 2 ways in which we classify triangles, we often name a triangle using both its side length and angle measure classifications. For example, we might say an obtuse, isosceles triangle. Obtuse referring to the angle measure and isosceles referring to the side length. So given this, answer these as true or false. If the statement is true, draw an example of the triangle. If the statement is false, explain why it cannot be done. So read through these. A is a triangle can have exactly 2 acute angles. B, a triangle can have an obtuse angle and a right angle. C, a triangle can be scalene and right. D, a triangle can be equilateral and obtuse. And E, a triangle can be isosceles and right. These are deep thinking questions. So make sure you understand these and think about them. Let's look at what a student might do if they were trying to classify a triangle by its angle measure. So, 2 5th graders, Louise and Mark, are trying to classify the triangle below by angle measure. Louise says, I think it's an obtuse triangle because the measure of angle ABC is 126, which is greater than 90 degrees, so it's an obtuse angle. Mark says, but there are 2 acute angles. The measure of angle BAC is 30 degrees and the measure of angle ACB is 24 degrees. So I think it's an acute triangle. So you can kind of investigate each student's logic. But the important part is, what's the definition of an obtuse triangle? The definition of an obtuse triangle is a triangle with one angle greater than 90 degrees. So Louise is correct. Since we have this 126 degree angle, it is larger than 90 degrees. Therefore, this is an obtuse triangle. But you can see where students might get confused because they're classifying angles and not the whole triangle. So Mark is correct in there are 2 acute angles, but the definition of an acute triangle is all 3 angles are acute. So when they're investigating those statements on the previous slide, they might get confused and have to refer to classification again. It's great to create a table for your students and or for you that classifies triangles by their side length, scalene, isosceles, and equilateral, and their angles, acute, right, and obtuse. So when you're investigating that true, false, in each one of these, you could draw a picture and say, yes, it's possible, or you can't draw a picture, so you'll say, no, it's not possible, and why. So, and this is a great way to see if any of the classification combinations are not possible to construct, which would help with that A through E part. So if we look at, for example, an acute scalene triangle, first I'm going to think about the definition of an acute triangle. Acute triangles, all 3 angles have to be acute. Second, I need to think about the definition for a scalene triangle. That's all the sides have to have different lengths. So I drew a picture and used the proper geometry notation. So I can tell that this side length, and this side length are different. And all 3 of these angles are definitely less than 90 degrees. So this is an example of an acute scalene triangle. Complete those true and false questions and make sure you understand why these triangles can or cannot be drawn. Thanks for watching.